Let's understand sequences and progressions in this video. Have you ever noticed a pattern in stairs, beads, or savings and wondered what comes next? That is what sequences help us study. Simple patterns and numbers. A sequence is an ordered list of numbers, one after another. Each number in the list is called a term. Some common sequences you already know are natural numbers 1, 2, 3 and odd numbers 1, 3, 5. There are special sequences like triangular numbers 1, 3, 6, 10 and square numbers 1, 4, 9, 16. Some sequences keep going forever. We call those infinite sequences, like natural numbers. Some end after a few terms, and those are finite sequences. We write the nth term as t sub n, where n is the position of the term. So t sub 1 is the first term, t sub 2 is the second, and so on. For the sequence 2, 4, 6, 8, we say t sub 1 equals 2, t sub 2 equals 4. Now let us talk about two ways to describe sequences: explicit and recursive rules. An explicit rule gives the value of a term directly from its position n. For example, u sub n equals 3 times n plus 2 gives terms 5, 8, 11, 14 and so on. Another example, s sub n equals 4 times n plus 1 gives 5, 9, 13, 17, 21, 25 for n from 1 to 6. We can use an explicit rule to find any term like the 50th term without earlier terms. To check if a number belongs to a sequence, we solve the formula for n and see if n is a natural number. For t sub n equals 4 times n plus 3, the number 199 gives n equals 49. So, it is the 49th term. But 250 gives n equals 61.75, which is not a natural number. So 250 is not a term. A recursive rule finds a term using earlier terms in the sequence. For example, the sequence 2, 6, 10, 14 adds 4 each time. So t sub 1 equals 2 and t sub n equals t sub n minus 1 plus 4. Another recursive example starts u sub 1 equals 2 and u sub n equals 3 times u sub n minus 1 minus 1, producing 2, 5, 14, 41 and so on. A famous recursive sequence is the Virahanka-Fibonacci sequence, where v sub 1 equals 1 and v sub 2 equals 2 and v sub n equals v sub n minus 1 plus v sub n minus 2. This gives 1, 2, 3, 5, 8, 13, 21, 34 and so on. Now arithmetic progressions or APs are sequences with a constant difference between terms. We call this constant the common difference d. An AP looks like a plus d, a plus 2d, a plus 3d and so on. The nth term of an AP is t sub n equals a plus d times n minus 1. Recursively we write t sub 1 equals a and t sub n equals t sub n minus 1 plus d for n greater than or equal to 2. For example, 7, 12, 17, 22 has common difference 5 and the next three terms are 27, 32, 37. To find the 10th term of 4, 9, 14, 19, we use t sub n formula and get 49. A real-life AP example is a gym charging 500 rupees registration and 150 rupees each month, giving costs 650, 800, 950 and t after n months equals 500 plus 150 times n. When we plot an AP, the points lie on a straight line, so it is linear. Next is geometric progression or GP. where each term is found by multiplying by a fixed number r called the common ratio. A GP looks like a times r squared, a times r cubed, and so on. The nth term of a GP is t sub n equals a times r to the power n minus 1, and recursively t sub n equals r times t sub n minus 1. Example 4. 8, 16, 32 has ratio 2. So t sub n equals 4 times 2 to the power n minus 1. Example 7. 7 divided by 2. 7 divided by 4. 7 divided by 8 has ratio 1 divided by 2. And t sub n equals 7 times 1 divided by 2 to the power n minus 1. GPs plotted on a graph do not make a straight line. They show exponential growth or decay. A fun recursive pattern is the Sierpinski triangle, where stage 0 is a full triangle and each stage removes the middle piece. The number of black triangles at stage n is 3 to the power n, giving 1, 3, 9, 27, 81, and so on. The area of the black region shrinks by 3 divided by 4 each stage. So, area at stage n equals 3 divided by 4 to the power n. At stage 7, the number of black triangles is 3 to the power 7 equals 2187, and the area is approximately 0.1335. This shows number of pieces can grow while total area gets smaller and closer to 0. A practical GP example is a machine making 30 units first hour and then multiplying by 3 divided by 2 each hour, giving 30, 45, 67.5, 101.25, 151.875. The production first goes above 5 times the initial output after the 5th hour. So, what do we learn from this? We learn sequences are ordered lists. Patterns can be written as explicit or recursive rules, and two main types are arithmetic and geometric progressions. We also learn how to find specific terms, check membership, add up natural numbers, and see recursive shapes like fractals. Let us quickly remember the main points. Definition of sequence, t sub n notation, explicit rule, recursive rule, AP with t sub n equals a plus d times n minus 1, GP with t sub n equals a times r to the power n minus 1, and the sum formula for natural numbers. The sum of first n natural numbers Sn equals n times n plus 1 divided by 2, and triangular numbers are linked to this sum. So today we learned simple tools to spot patterns and to predict what comes next with confidence. Keep practicing with small examples and draw patterns on paper. It makes the ideas clear and fun. Nice work today. Do not worry if some parts feel new. Practice will help you improve. Explore more lessons and practice problems on EduRev when you feel ready. And enjoy learning at your own pace.